You mentioned that there might be some fundamental limitation to the human brain
Yes.
that limits our ability to understand some aspect of how the universe works. That's really interesting.
Mhm.
That's sad, actually. If to the degree it's true, it's sad. So what do you mean by that?
I would simply say that just as a monkey can't understand quantum theory or even Newtonian physics, there's no particular reason why the human brain should have evolved to be well matched to understanding the deepest aspects of reality. And I suspect that there may be aspects that we are not even aware of and couldn't really fully comprehend. But as an intermediate step towards that, one thing which I think is a very interesting possibility is the extent to which AI can help us. I mean, I think if you take the example of so-called theories of everything, one of which is string theory involves very complicated geometry and structures in 10 dimensions. And it's certainly, in my view, on the cards that the physics of 10 dimensions, very complicated geometry, may be too hard for a human being to work through, but could be worked through by an AI with the advantage of the huge processing power, which enables them to learn world championship chess within a few hours just by watching games. So there's every reason to expect that these machines could help us to solve these problems. And of course, if that's the way we came to understand whether string theory was right, it would be in a sense frustrating because you wouldn't get the sort of aha insight, which is the greatest satisfaction from doing science. But on the other hand, if a machine churns away at 10-dimensional geometry, figuring out all the possible origamis wound up in extra dimensions, if it comes out at the end, spews out the correct mass of the electron, the fact that there are 3 kinds of neutrinos, something like that, you would know that there was some truth in the theory. And so we may have a theory which we come to trust because it does predict things that we can observe and check, but we may never really understand the full workings of it to the extent that we do more or less understand how most phenomena can be explained in a fundamental way. Of course, in the case of quantum theory, many people would say, understandably, there's still some mysteries. We don't quite understand why it works. But there could be deeper mysteries when we get to these unified theories, where there's a big gap between what a computer can print out for us at the end and what we can actually grasp and think through in our heads.
Yeah, it's interesting that the idea that there could be things a computer could tell us that is true. And maybe it can even help us understand why it's true a little bit.
Yep.
But ultimately, it's still a long journey to really deeply understand the whys of it.
Yes, and that's a limitation of our brain.
We can try to sneak up to it in different ways, given the limitations of our brain. I've gotten a chance to spend the day at DeepMind, talk to Demis Hassabis. His big dream is to apply AI to the questions of science, certainly to the questions of physics. Have you gotten a chance to interact with them?
Yes, well, I know him quite well. He's one of my heroes, certainly. And I remember...
I'm sure he would say the same.
And I remember the first time I met him, he said that he was like me. He wanted to understand the universe, but he thought the best thing to do was to try and develop AI. And then with the help of AI, he'd stand more chance of understanding the universe.
Yeah.
And I think he's right about that. So, and of course, although we're familiar with the way his computers play Go and chess, he's already made contributions to science through understanding protein folding better than the best human chemists. And so already he's on the path to showing ways in which computers have the power to learn and do things by having ability to analyze enormous samples in a short time to do better than humans. And so I think he would resonate with what I've just said, that it may be that in these other fundamental questions, the computers will play a crucial role.
Yeah, and they're also doing quantum mechanical simulation of electrons. They're doing control of high temperature plasma fusion reactors.
Yes, that's a new thing, which is very interesting, that they can suppress the instabilities in these tokamaks better than any other way. Yeah.
And it's just the march of progress by AIs in science is making big strides. Do you think an AI system will win a Nobel Prize in this century? What do you think?
Yes, yes.
And does that make you sad?
If I can digress and put in a plug for my next book,
Yes.
it has a chapter saying why Nobel Prizes do more harm than good.
Yes.
So on a quite separate subject, I think Nobel Prizes do a great deal of damage to the perception of the way science is done. Of course, if you ask who or what deserves the credit for any scientific discovery, it may be often someone who has an idea, a team of people who work a big experiment, etc.
Yes.
And of course, it's the quality of the equipment which is crucial. And certainly in the subjects I do in astronomy, the huge advances we've had come not from us being more intelligent than Aristotle was, but through us having far, far better data from powerful telescopes on the ground and in space. And also, incidentally, we've benefited hugely in astronomy from computer simulations, because if you are a subatomic physicist, then of course you crash together the particles in a big accelerator like the one at CERN and see what happens. But I can't crash together two galaxies or two stars and see what happens. But in the virtual world of a computer, one can do simulations like that. And the power of computers is such that these simulations can yield phenomena and insights which we wouldn't have guessed beforehand. And the way we can feel we're making progress in trying to understand some of these phenomena, why galaxies have the size and shape they do, and all that, is because we can do simulations, tweaking different initial conditions and seeing which gives the best fit to what we actually observe. And so that's a way in which we've made progress in using computers. And incidentally, we also now need them to analyze data, because one thinks of astronomy as being traditionally a rather data-poor subject. But the European satellite called Gaia has just put online the speeds and colors and properties of nearly 2 billion stars in the Milky Way, and which you can do fantastic analyses of. And that, of course, could not be done at all without just the number crunching capacities of computers.
And the new methods of machine learning actually love raw data, the kind that astronomy provides. Organized, structured, raw data.
Yeah, well, indeed, because the reason they really have a benefit over us is that they can learn and think so much faster. That's how they can learn to play chess and Go. That's how they can learn to diagnose lung cancer better than a radiologist, because they can look at 100,000 scans in a few days, whereas no human radiologist sees that many in a lifetime.